Hello everyone, welcome to my channel Simply Sciences once again. Today we are going to discuss different sums on the chapters large numbers, operations on large numbers and multiples and factors. So as you can see that the first question on the screen is Sudeepa arranges 28 apple seeds in the form of different rectangles. Now show the formation of these rectangles and how many different rectangles can she make. This will basically be based upon the factors of 28. The factors of 28 can be 28 can be written as 1 multiplied by 28, 2 multiplied by 14, 7 multiplied by 4. So these will be my structures of rectangles. So if I want to arrange 28 apple seeds in suppose a straight line, I will just, this is a straight line and I'll have the first apple seeds and the 28th apple seed on the same straight line. Now if I want to have two lines of apple seeds, so I'll divide 28 by 2. 28 divided by 2 gives me 14. So if I have two lines, in the first line I'll have 1 to 14th and 15th to 20th apple seeds. So these are my two lines of seeds, and there are two rows, and in each row there are 14 seeds. Now in the third case, if I want to divide 28 apple seeds into 4 lines, in the first line I'll have 1 to 7th seed, in the second line 8 to 14th, in the third line 15th to 21st, and in the fourth line 22nd to 28th. Now over here in the first case I have 1 to 28 in a straight line, that is row. In the second one I have two horizontal rows. I can also have two vertical columns. In the third one, see, there are 4 rows. I can also have 4 columns, and in that case if there are 4 columns, then there will be 7 rows. It's just the reverse thing. If there are 7 rows, there will be 4 columns. If there are 7 columns, then there will be 4 rows. So as I was saying, 28 can be written as a combination of 1 multiplied by 28. 1 and 28 are the factors of 28. Then 2 into 14. 2 and 14 are also factors of 28. And in that case I can draw either 2 rows or 2 columns with 14 seeds in each of them. And I can also have 4 into 7. I can either have 4 columns or 4 rows. Okay, if there are 4 rows, there will be 7 seeds in each row. And now we will try to draw the rectangles. It's very easy. It's just like drawing a picture. You just need to visualize what you are thinking. Just visualize the numbers. So here we have the rectangle. We have 4 rows, and in each row there are 7 seeds. 4 rows, 7 columns. Now I'll simply reverse it. There will be 4 columns and 7 rows. Okay, so 7 rows, 1 column was less, so I added it. There are 7 rows and 4 columns, and in each row there are 4 seats. I need to add a page over here to finish the sum, so I added a page. I hope everyone is following what I'm doing till now. Now we'll just go to the different factors. 7 into 4 is done, so we have moved on to 2 into 14. I have 2 rows over here, and I'm trying to draw 14 columns. I am counting. There are 14 columns, so 2 rows, and in each row there will be 14 seats. 2 rows, and in each row there are 14 apple seeds. Again, I'll just simply reverse it. So instead of 2 rows, I'll draw 2 columns. These are just the different ways I can keep the seeds. Suppose this one is a box. Okay, the whole rectangle, the large rectangle we can see. Suppose this is a box. We can always keep the box in different ways. Now we can keep it horizontally, we can keep it vertically. It's just that the rectangle can be very long, the rectangle can be almost a square. It's just about visualization. So the last combination, there are 14 rows, and in each row there are 2 seats. 14 rows, 2 columns. In 14 rows, in each row there are 2 seats. So these are the possible 4 combinations using the factors of 28. Now this is the second sum. Write your birthday in the format like we usually write. 2 digits for date, 2 digits for month, and 4 digits for year. Any random date I'll write 23/07, that is July, and 2004. Okay. Now one very important thing to remember for Roman numerals is that we consider the place values of the digits, not only the face values. Okay, and I'll also write down the letters. M is for 1000, D is 500, C 100, L 50, X is 10, V is 5, and I is 1. This will help us to solve the problem easily if we can just remember this. And as I said, we will consider the place value and not the face value. So 23, 20 is important. It's not 2, 3. 23. So XX 10 plus 10 gives me 20. I is 3. 20 plus 3 is 23. 07, we do not consider the 0. It is just the 7 part. So V is 5. 5 plus 2. And 2004. So M is 1000. I can simply write 2 M's just like I wrote 2I to make it 2. 1 plus 1, 2. Also means 1000 plus 1000, 2000, and 4, IV. We do not consider the bar method here because it is just 2000. We can use the bar method for 4000 because for Roman numerals we cannot repeat one digit for 4 times. So this is my Roman numeral, and going to the next question. I am a 2-digit prime number less than 55. Okay, so there is a number which is less than 55 and the product of my digits is 15. So this is a good clue that the product of the digits is 15. Now for that I simply have to know what are the factors of 15. They are 3 and 5. Both are prime numbers. 3 and 5. It cannot be 1 and 15 because if it is 1 and 15 it will make 3 digits, 1 1 5. But over here it is said that it is a 2-digit prime number. With the combination of 3 and 5 I have two numbers which is less than 55, 35 and 53. 35 is a composite number whose factors are 5 and 7. 53 is a prime number. The digits of 53 are 5 and 3. If I multiply 5 and 3, I get 15. So the product is correct. And 53 is also less than 55. I'm just deleting the page over here. I hope the sum was clear. And I'll just go to the fourth question. List the composite numbers between 1 to 100 ending with 3. This is very easy. We just have to list all the numbers which ends with 3. So 3, 13, 23, 33, 43, 53, 63, 73, 83 and 93. Composite numbers. Composite numbers means the numbers which have more than 2 factors. That is, they are divisible by themselves, 1 and more numbers. For example, 33. 33 is 3 into 11, 63, 7 into 9, 93, 3 into 31. So we got our answers. These are the composite numbers, and all the rest which I have not marked in red, they are prime numbers. 3, 13, 23, 43, 53, 73, 83 are all prime numbers. The composite numbers are 33, 63 and 93. This is my answer. Take a good look at it. This one can be tricky, but it is easy. Now, going to the next question. There are 3 bells. The first bell rings every 25 minutes. Second bell rings every 75 minutes. The third bell rings every 100 minutes. So we have three numbers, okay? 25, 75 and 100. The bells are ringing at an interval. If all the three bells ring together at 10 a.m., when will the bells ring together again? Now, just to get rid of the confusion, let us just forget that in the question it is given 10 a.m. Suppose it is simply written three bells are ringing every 25 minutes, 75 minutes and 100 minutes. So after how much time or after how many minutes will all the three bells ring together again? Simply, it's as simple as that. When the stopwatch was at 0, okay, we will just the three bells rang together, and then after how many minutes will the bells ring again? For that we need to find the LCM. So we have chosen the division method over here. We are dividing the three numbers together. First step with 5, we are getting 5, 15 and 20. In the next step, again with 5, we get 1, 3 and 4. And after that, there are no more common factors, so we will not divide them anymore. And our LCM will be 5 into 5 into 3 into 4. We can simply do the calculation and we get 25 into 12 to make it shorter, and we will get 300. So the bells will ring again all together, okay? Together after 300 minutes. It rang together at the beginning, at when the stopwatch was 0, okay? And after that, at different intervals, it was ringing. And after 300 minutes, it rang again together. Their steps synchronized after 300 minutes. Now, the bell rang together first at 10 a.m. and after that, after 300 minutes, it will ring again. So we simply have to convert 300 minutes into hours to get the time. Now for that, simple unitary method, 60 minutes means 1 hour, so 1 minute means 1 by 60 hour. Obviously I divide it. Then 300 minutes, I'll again multiply 300, so 300 divided by 60 hours. This is simply the explanation part. We do not have to do it in the main sum. So when we convert minute into hours, we divide the number with 60. We divide minutes by 60 to get hours. So 300 minutes divided by 60 gives us 5 hours. So the bell will ring after the bells will ring all together after 5 hours. 3 bells rang together at which time? 10 a.m. or by military time 1000 hours. Okay, they will ring again at 10 a.m. plus 5 hours. So you can simply count by your hand, or you can add them. If we add them, we get 1500 hours. 1500 1500 is in the 24-hour configuration. If we try to convert it into 12-hour configuration, we get 3 p.m. 1500 hours, that is 24-hour format. Okay, and 3 p.m. is 12-hour format. We all know this from the digital clocks, right? So we got our answer. The bells will ring together again at 3 p.m. Now question number 6. As you can see, I have used all possible words in this question, like estimate, approximate, almost, about, how many, just for you to understand that all these words are used in questions where estimation is included. Okay, so do not miss the clue which is given in the question, or do not miss any cue that you can get from the question, which is telling you what you have to find out, what you need to do with the numbers that is given. So I have the population over here, 65 lakh 33,707 men, 59 lakh 66,999 women, and 35 lakh 30,001 children. Okay, now we have to estimate, right? Estimation, we know that on the right hand side, if the digit on the right hand side is 5 or greater than 5, we add 1. So approximate number of men is 65 lakh. See, we will estimate till the place of 1000. So as you can see that in the place of 1000 we have 3, but on the right side of 3000 we have 700. So 7 is larger than 5. So I'll add 1 to the 3000, it will become 4000, and the rest of the digits will become 0. Approximate number of women again, see, in the thousands place I have 6, and on the right hand side of 6 I have 9. So the 6000 will become 7000. We have seen these digits very commonly on the price tags, right? 6,999. Yeah, so we know this. Approximate number of children. Over here, see, in the thousands place it's 0, and also on the right hand side of 0 there is another 0. So it will all be converted to 0. 30,000 will remain 30,000. 35 lakh 30,000. We have rounded up the 1. So these are the approximate number of men, women and children. Now we can simply add them up. The total population of the city at the last there are 3 zeros, all are thousands, so I'll simply write the zeros. In the thousands place I have 4, 7 and 0. 4 plus 7 is 11. I have 1. I have carry over 1. So 1 plus 3, 4. 4 plus 6, 10. 10 plus 3, 13. 3. I have carry over 1 again. 1 plus 5, 6. 6 plus 9 is 15. 15 plus 5 is 20. I have carry over 2. 2 plus 6 is 8 and 5 plus 3 is 8, so 8 plus 8 is 16 again, so I get 1 crore 60 lakh 31,000. This is my approximate population of the city. About 1 crore 60 lakh 31,000 people live in the city. Almost 1 crore 60 lakh 31,000 people live in the city. And we can also mention that we have estimated till the thousands place. This is our answer. Please write separately a sentence separately for the answer during your examinations. I hope this was clear. Now we are moving on to the next question. Find sum of all the prime factors of 28. So we will simply divide 28 with 2 because 28 is an even number and 2 is the smallest prime number. So we're dividing 28 with 2. We get 14. 14 is also an even number. We will divide it with 2. We get 7. So 28 equals to 2 into 2 into 7, right? Product of these 3 digits. If we add them up, sum of all the prime factors, 2 plus 2 plus 7 is 11. This is our answer. Going to the next question. I'll just delete one extra page. Find the product of all the possible factors of 25. We already know that products factors of 25. First is 1 into 25 because 1 and 25 are possible factors. You have to notice that it is written over here all the possible factors and not only prime factors. In question number 7 it was written only the prime factors, and over here it is written all the possible factors. So I have 1 and 25 and 2 5s. 25 into 25, which gives me 625. Please find out the product, do the calculation and find out 25 into 25 equals to 625. I already know it by heart, so I have written it. Now question number 9. Find the multiple of 3 and 7, which is 4 less than the square of 5. The new number which over here you will find is square of 5. That is the new number. Square of 5 means 5 multiplied by 5. Square of any number means the number multiplied twice. Square of 4 means 4 into 4. Square of 2 means 2 into 2. And now in the question it is given 4 less than square of 5. Square of 5 is 25. So 4 less than 25. That means a number which is 4 steps less than 25. So 25 minus 4, which gives me 21, and we know that 21 is a multiple of 3 and 7, because 3 multiplied by 7 is 21. Now question number 10. This one I have tried to pack this question up with all types of operations. Rohan read 5 books in a year, and in each book there were 730 pages. This is a word problem, so we will need to write statements. Rohan read 5 books in a year. Number of pages in one book, 730. How many pages are there in one book? 730. So number of pages in 5 books, so it will be greater than 730. In one book there are 730 pages, so in 5 books there will be more than 730 pages. So I have to multiply 730 multiplied by 5, which gives me 3650. Please do the calculation. So total number of pages Rohan read in the whole year is 3650. Number of pages Rohan read in 365 days. Why did I write 365 days? Because in a year there are 365 days. In a year there are 365 days. That's why I wrote 365 days. Number of pages he read in one day, 3650 divided by 365. Why did I divide with 365? Because in a year there are 365 days, and it is said that find the how many pages did he read per day. Okay, I have to find the unit over here is day. I have to find out how many pages he read in one day. If it were in 1 month, in a year there are 12 months. So if the question was how many pages did he read in 1 month, then I would have divided 3650 with 12, because then the unit would have been month, not days. But in this question it is given days, so I have divided with 365 days, and I got the answer 10. 3650 is the total number of pages, 365 is the total number of days, and in one day he read 10 pages. Approximate number of pages he read in the whole year. See, it is 3650. We will approximate till the 100th place. Okay, so 6 is in the 100th place and 5 is in the 10th place, so we have to simply add 1 to 6. So 600 will become 700, and we get approximately 3700. 10 is the number of pages he reads per day, and 3700 is the approximate number of total pages he read in the whole year.
Thank you for joining us in this mathematics online tutorial. We hope you found it both informative and enjoyable. We will solve more sums in the next video. If you have any questions or suggestions for future tutorial topics, please leave them in the comments section below. We value your feedback and want to ensure that our content aligns with your interests and needs. Don't forget to like and share this video and subscribe to our channel to stay updated with our latest tutorials and mathematics and physics related content. Keep supporting us. Thank you so much once again.